What's the average product of the numbers showing on the throw of 2 dice? Let's have fun using Python to find out. Let's take a look at 2 ways to find the answer using Python. We'll use a Monte Carlo method to get an estimation. And we'll also do a more direct calculation. Both programs are very short, but before we do that, I suggest you pause and give this a try yourself. Okay, here's the code for the Monte Carlo simulation. We'll import the random number generator, of course. Random numbers are at the heart of any Monte Carlo simulation. We'll go through a million trials, but you can change this to any number you want. The bigger the number of trials, the better will be your estimate, but the trade-off is in how long the program will take to run. We will sum up the products, once for each trial. D1 is the number showing on the first dice, a number from 1 to 6 inclusive. D2 is for the second dice, again from 1 to 6 inclusive. The product is found by multiplying D1 times D2, and then we add each product into the sum. After all million or so trials are run, we print the sum divided by the total number of trials. As shown here, the output average of the products is approximately 12.252, very roughly. You should expect this result to vary from run to run of the program. Now let's run an even shorter program that calculates the average product of the 2 dice in a different way, more directly and much quicker. Take a look at this table. If you think of each row as one of the dice numbers, and each column as the other dice, where each dice has a value from 1 through 6, notice that every cell in this table is the product of the numbers showing on each pair of dice. These 36 values cover all possible cases of rolling 2 dice, and each of the 36 possibilities has the same probability of being rolled as any of the others. All we need to do is add up all the products in each of the cells of this table and divide by the number of cells to see what the average should be. This is true since each cell has an equal likelihood of being rolled. Our second program simply loops through all the rows and columns, finds the product in each case, and adds them all together. This sum is then divided by 36 to calculate the average product for all possible rolls of the pair of dice. This results in the exact value of 12.25. As you can see, our Monte Carlo method approaches 12.25 after enough trials. The more random tests you run on it, the closer it gets on the average to the exact value of 12.25. If you want to experiment further, try to find the average product when 3 dice are rolled, or find averages for 12-sided dice. Perhaps you might graph some results to find patterns. And that concludes our Python challenge for today. Remember, one of the best ways to learn Python is to have fun with it.